All right, 5.4, adding and subtracting polynomials. So all this exponent stuff is really just to lead up to polynomials. We've seen some, for those of you that, again, maybe took 950 or 920 or even 900, had a little experience with calculating with exponents, but right now we're looking at what we call polynomials, which leads us to the quadratic equation. Well, not in this class, but for some other class, okay? All right, we only really talked about 4 different types of nomials. A monomial is an expression with one term. Sometimes that one term expression is 5. Sometimes it's just x. Sometimes it's like x to the power of 3. Remember, terms are separated by addition or subtraction, so we won't ever see addition and subtraction in a monomial. Mono is 1, right? So it's possible to have lots of different letters in there. You could have like x to the power of 3, y to the power of 2, just like we saw, what was that, 2 lessons ago? This would be considered a monomial because it's being multiplied by values in there, okay? Now, a binomial has 2 of these terms. So now you just say, well, you could combine your 5 and your x right there with maybe addition. Maybe if you want to combine it with subtraction, yeah. There's still 2 terms, okay, 5 and x. Or you could look at this other one. I'll use a different exponent here, but maybe x to the power of 4 and the x to the power of 3, y to the power of 2. Subtract, add, doesn't matter. Maybe that's even negative. That doesn't matter. But now it's a binomial because this is a term and this is a term. 2 terms. By 2, okay? Try then, it would be 3 terms. So, yeah, go ahead. Well, they usually look like this. I'll show that. Like something like x squared plus 4x plus 16. Something like this. And now it's 3 terms, okay? Now, again, sometimes a term may look like this, even with these type of trinomials. But I don't think we see a lot of them, but it does seem like we do see some. Now, any polynomial is, it says it's an expression with 4 or more. You could say poly is just many, right? So you could say, well, a binomial and trinomial are classified as polynomials. But in mathematics, we want to segregate those. Classify binomials as their own type of nomial. I don't actually know what the technical word is here, but trinomial would be classified on its own. And then polynomial, again, 4 or more. We don't necessarily deal with polynomials unless there's 4. Sometimes there's 4 terms, but usually nothing beyond that, unless we need to simplify into a trinomial, binomial, or monomial. So we have seen some of those problems with simplification, right? That started as a polynomial, but maybe ended up as a binomial, such as, 3x minus 4 plus 5x minus 6 plus 8x. This would be considered a polynomial, even though in its simplified format, it only ends up being a binomial, okay? There shouldn't be negative or partial exponents. Yeah, that's true. Just like we saw on that section with negative exponents, it doesn't ever want us to write answers with negative exponents. It only wants us to use positive exponents, which is what we will do, okay? So if we see a negative exponent, remember that let's look at that rule again. The rule, right, if you got an x to the power of like -1, you just make it 1 over x. Or even if it was x to the power of -10, then you make it 1 over x to the power of 10. Remember that? It just flips the fraction, because you could show that as x to the power of -10 over 1, flip the fraction, boom, got it. And we haven't seen partial exponents yet, not that I remember. But fractional exponents or decimal exponents, which do exist, we just haven't covered them. I don't know if we do, certainly not in this unit, but we shouldn't expect to see any of those, not in answers, and right now we really probably shouldn't expect to see any of those in the problems either. All right, so there's of course, that was some vocabulary. Here's more vocabulary, just in case you didn't want more. The term, the degree of a term is where you take the exponents of whatever the term is for the variables and you add them together. Now, if there's only one variable, like let's say x to the power of 3, right? We would say that this term has a degree of 3. Well, what if the coefficient was 7? We don't care about the coefficient, not at all. Not when we're looking at the degrees of these. The coefficient doesn't affect the degree of a term, only the exponents of the variables do. Well, what if 7 was to the power of 4? Once again, we don't care about the coefficients. It could be negative, it could be positive, none of that matters. All that matters is the variable exponent. Well, what about that last one that we saw where it was like x to the power of 3, y to the power of 2? The degree of the term is the sum of the exponents. So this degree right here would be considered degree 5. Because you had this exponent 3 and this exponent 2 of the two variables. What about the coefficient? What if it was like negative 18? We don't care. That never affects the degree of a term, okay? Well, what about the degree of a polynomial? Maybe it's got 4 terms, maybe it's even only got 3 or 2. The degree of a polynomial, you just find the term that has the largest degree, and it doesn't matter where it's located in the expression. The one that has the largest degree is the actual final degree of the polynomial, okay? So sometimes this gets a little confusing. Like I said, especially when the degree of the term is in the middle of the expression. So you could say like x plus x squared plus x to the power of 18 plus 4, right? And they say, well, what's the degree of this polynomial? Sometimes students get mixed up and they say it's degree 1 because the first term has a degree of 1. Nope, it's not a degree of 1. This polynomial has a degree of 18 because of this term right here. It's 18. Now we know what a coefficient is. A coefficient is a number that is being multiplied by a letter. That is all. And so up here, right, 7 would be considered the coefficient of this term. Negative 18 would be considered the coefficient of this term. Okay? Usually it's in front of, yeah, that's another way to say it, whatever. The leading term is the degree of the highest, it's the degree of the highest degree term. It says degree right there. It shouldn't. It should say coefficient. Or it's just the term. The term, the degree of the highest degree term is just the term. The highest degree term, there we go. I'd like that better. The highest degree term would be considered the leading term. The leading coefficient is the coefficient of the leading term. So even if we come back here to this problem right here, you'd say, well, what's the leading term? It's really 8x to the power of 18. Well, but it's not in front. It's not leading. That's true. It's in there, though, okay? So this would be considered the leading term. Well, what's the leading coefficient there? Because sometimes it's not always shown. That's one of those phantom 1 situations. That would have a leading coefficient of 1. Let's see, addition and subtraction determine if a term is positive or negative. Yeah, remember that every term, no matter what it is, it will always take the operation to the left, whether it's positive or addition or subtraction, as positive or negative, respectively. I personally don't care for the vocabulary that much, but there's problems that have the vocabulary on it. Something like this, okay? Now, it's listed, right, because this expression here has 5 terms. 1, 2, 3, 4, 5. Sometimes students even like to just kind of box them in, right? So that would be its own term. That's considered its own term. Notice I included the minus as the negative part of that term. And so negative 8 is considered its own term, and negative 3x to the power of 4 is its own term, and also 6x. All its own terms, okay? So the first term, well, do we have a degree for that term? I'll do this one in red. Okay, this one in red. Well, the degree of that term is the exponent for the variable x, which is 3. Oh, wrong color. 3. What's the coefficient? Well, I see that the number that's being multiplied by the letter there, x, is 2. Coefficient is 2. All right, the second term, this one in purple. So the degree of this one is degree 2 because the exponent of the x is 2. The coefficient there, the number being multiplied by the x, negative 2. The third term, this one throws people off because it's not actually showing the letter on this one. So, but actually the 8 is considered a coefficient right here, negative 8. Yeah, but it's not being multiplied by a letter. It is, you just can't see it, okay? It's being multiplied by x to the power of 0. That's what I meant there. So it actually does have a degree of 0 on this one because it's not showing the variable. Okay. So, well, the fourth term here, that has a degree, the exponent there is 4. So the degree 4, the coefficient, again, it's not just 3, it's negative 3 right there. And then our last term here, the fifth term, the coefficient is 6. That's the easy one. Sometimes students get this mixed up and they say, well, the x is not showing the coefficient, so it's degree 0. It's not 0. This, in this case, is a exponent, phantom 1 exponent. So it has a degree of 1. Yeah, so this term was negative 8. Now, you could make it a fraction over 1, but that over 1 doesn't help us determine the degree. You could say that it helps you determine the coefficient because it's still negative 8. You could say negative 8 over 1, and that would still be true. It's just, on this one, like I said, it is being multiplied by a letter. It's just, it's a power of 0. Why is this a power of 0? Because it's really just negative 8 times 1. I didn't want it to show 1. I wanted to show x to the power of 0. Well, what the crap is x to the power of 0? Remember, anything to the power of 0 is 1. So this goes back to the beginning of the semester. And I kind of skipped this step on purpose because it can cause some confusion. But sometimes mathematics is about you taking control and making things what you want them to be. And so while in the past negative 8 was really considered a constant, because it is, you could say, well, negative 8 times 1, well, what is 1? Maybe you want it to be x to the power of 0, especially in this case. Maybe you wanted 1 to be 3 minus 2. I don't know. I don't know why you need it to be 1. But in this case, we need it to be x to the power of 0, so we do need the 1. So this negative 8, by the way, this negative 8 even, is being multiplied by 1s. That's not just this one right here. It's being multiplied by many 1s here. We just can't see them. So if we want to see them, we can put them there and then change the way it looks, as long as we don't change its value. And that's the key. In mathematics, you can change the way things look so long as you don't change the value. You can force it to be what you want it to be. Let's take that. I take that back. We need the highest degree, which, yeah, it's 4 right there. I'll highlight it in appropriate color. There it is. This is the one we want. So what's its coefficient? It's showing there. It's already negative 3. So the degree, it's already showing there is 4. So what's the degree of the polynomial? It's the highest degree, or the degree of the leading term. Boom, it's 4. So why do they say why is the leading the highest? Because if we said the degree of the highest term, then you'd understand it too fast. And we wouldn't look as smart as you think we are. Because to me, it's like leading indicates that it's the first term. Now technically speaking, and so there's a slight reason behind this. For mathematics, we generally would write the highest degree term first. So we would rearrange this, what I'm saying, so that the negative 3x to the power 4 is in the front. And then we write it in what we call descending order, which means we just go down in degree for each term. So this one is not technically in what you would consider mathematical format. I mean, it's still an expression and it still works. But math people, if you were to write something like this in the future, even like in a 10-10 class, your teacher, their head may explode. Being able to just combine the like terms is pretty crucial, okay? Now, we did talk about this a little bit before because we saw problems like this when we looked at combining like terms. What the heck was that, 1.1, 1.2? This is the same kind of thing, but I'm going to use the vocabulary that was given in this. Hopefully it makes sense. Is you can only combine like terms. Like terms are considered terms that have the same degree. But they also have to have the same exponents of the same variables. So right now this problem only has x variables. If they had x and y's in there, that it changes just a slight bit, okay? So even though this is considered really an x term and this is an x term, they're different terms because of the exponents of the x's. Okay, so I'm going to start, because I always do this from left to right. I got 9x to the power of 3. Are there any other x to the power of 3 terms? Not that I can see right there. So I'm just going to keep that 9x to the power of 3. which, by the way, would be 9 would be the leading coefficient, and then the degree of the polynomial is 3. And this term degree is 3 as well. Okay, so what's my next term? I got this positive 10x to the power of 2. So I'm looking only for x to the power of 2 terms, such as positive 8x to the power of 2. So how many x to the power of 2's will this be? You got 10 and 8 of them, which is going to result in positive 18 of those. Now remember, the positive is shown with a plus sign on this. So it actually reads 9x to the power of 3 plus 18x to the power of 2. Plus, because it was 18 that's positive. And just, again, I'm just moving from left to right here. Negative 7x, so I'm on my x terms. There's only one other x term right here. How many x's will this result in? Negative 7 minus 3 would be negative, there's a negative 10 x's. And then finally, my constants, negative 2 plus 2, well, that's 0. You don't really need to put plus 0 right there. You're going to make that a phantom 0. There we go. And this, not only is this final expression simplified, but as I talked about before, this is considered descending order because you got exponent of 3, 2, and then there's a phantom 1 right there, right? 3, 2, 1. And then even if you had included the 0, that would have been an exponent of 0 for the x. But if you can simplify these, then you're in good shape. So on this one, it's f of x. That's function notation. And this is the function. Negative 9x to the power of 2 minus 5x plus 9. Okay, and this is, yeah, it's f of x equals that. Now, up right here it says find f of 1. So that means that really we're replacing that x right there with, well, 1. So that means I need to take all the x's in function and replace them with 1s. So that x would be a 1, and that x would be a 1 right there. 1's a pretty good number to work with, by the way, because it's so easy to work with. The only way they could have made this easier is if it was 0, which I wish they did. But it's not, so here we go. All right, so order of operations is what this is, which the calculator knows how to do, but I'm going to do it by hand because it's multiplying by 1. So 1 to the power of 2 would be 1. Then we'd have negative 9 times that 1 minus 5 times that 1. I'm showing the multiplication different just to save time, really. And then that would be exponents, then multiplication. So negative 9 times 1 is negative 9. 5 times 1 is 5. Well, negative 5 times 1 is negative 5. And then still plus the 9 right there. Now I'm going to take a bit of a shortcut because this negative 9 will zero out that positive 9, which leaves me with just negative 5. You could have just done negative 9 minus 5 plus 9. It'll give you the same answer, which means that f of 1 ends up equaling negative 5. Now, I did that by hand, but as you have seen, I make lots of mistakes. Well, enough small mistakes that it's noticeable. So I'm just going to put this in the calculator just to make sure. Okay, negative 9 parentheses 1, close parentheses, power of 2 minus 5 parentheses 1. You could say times 1, but plus 9, enter. Well, I'm still in scientific mode, so I got to get out of it. It's negative 9 to the power times 10 to the power of 0. It's still negative 5. So yeah, looks like we did that one just fine. I hope these aren't too bad because we have seen these quite a bit. Well, maybe not quite a bit, but at least enough. And I think it was module 1 again. So this one, h of t, let's rewrite this. So there's our function, but now it says h of negative 2. So I'm going to replace that t there with negative 2, which means all the t's have to be replaced with negative 2. So there we go. Replace all 3 of these. And instead of t's, we got negative 2's. Let's see if I can fit these in. One more. Oh. Negative 2. Did I get those other ones? Yeah, that's good. Okay. All right, and now again, I'm going to be using the order of operations, although you could just punch this straight into the calculator and it would do it for you. Whatever you want to do, okay? So I'd say on this one, negative 2 to the power of 3, which would really be negative 2 times negative 2 times negative 2. That's 3 negatives, which makes this answer a negative. And then 2 times 2 times 2 is 8. This one's just 2 of those, which means that's going to be positive. Negative 2 times negative 2 is positive 4. And then that last set right there, nothing really to do there with exponents, right? So it's just staying there. So then I now have negative 9 times that negative 8 plus 8 times the 4. So that's all my exponents. Let's go then into multiplication. Negative 9 times negative 8 would be positive 72. 8 times 4 would be positive 32. But this one right here, 3 times negative 2 would be negative 6. And as much as, well, I guess 40 minus 6, 34. That's not too bad. That's one, oh, that's, I did that backwards. That's 104. Then minus 6. Looks like that's going to be 98. Well, that's h of negative 2. Like I said, I'm just not trusting myself right now. So I'm going to put this in the calculator. All right. Feeling pretty good now. I'm on a streak. This one looks pretty good. So a quick note on that is if you don't use parentheses on this, like let's say, and I assume that's what's happening right there. So if you write negative 2 to the power of 2 like this, the calculator, because of the order of operations, thinks you want 2 times 2 and then just make it negative, which is why it may be showing negative 4 on that. If you make it the negative 2 in parentheses, then the calculator knows you want negative 2 times negative 2 like this, which is positive 4. You got to be careful with that. And I should have specified that. That's why we need the parentheses around those negatives like that, yeah.